write and solve direct variation equations. So we went through finding a constant of variation. Pretty simple to do. Change in y over change in x. We divide, we find the constant of variation. We're able to do that because it's a proportional relationship. Proportional relationships in linear functions always start with 0, 0. They cross through the origin. Write a direct variation equation. We did that by writing the equation y equals kx and using the information we were given to substitute into the equation and then solve for k. Now what we're going to do is we're going to use the information given, substitute it into the formula, solve for k, and then use the equation that we wrote to find out another piece of information. So you can see how these three pieces are building onto each other. So this should look very similar to the last section, write direct variation equations, because the process is going to be the same. The thing that's coming up now is we're given a third piece of information. So we're given an x and y, those will be our first two pieces of information. Then we're going to be given an x or y value. That'd be the third piece of information that we use to substitute into the equation that we wrote. Let's go ahead and take a look at some. So we know that we're starting off with y equals kx, just like in the last section. Y varies directly with x, and that tells us that it's a direct variation, constant variation, a constant of proportionality. All of those things are synonymous. So we're going to take the values 12 and 6 and substitute into the equation. So 12 equals 6k. We're dividing both sides by 6. We've got k equals 2. Now we're rewriting the equation. Y equals 2x. Now here's where this third piece comes in. Find y when x equals 4. And it's important to read what information is being given to you, obviously, because it could say find x when y is 4. So we're just making sure, okay, we're going to solve for y. We're given x. So y equals 2 times 4, the x value that was given. Y equals 8. So if y varies directly with x and y is 12 when x is 6, y would be 8 when x is 4. And if you wanted to set that up and understand the proportionality behind it, we can have our y and x. We can make a little table, 12 and 6, and then we have a value of 4 here. I don't know what that is. So 12 times 4 is 48. And then we're going to divide by the number that's left, and that's going to be 6 times. 6 times our question mark, divide by 6. Question mark equals 8. Because we know that whatever's happening to x is being multiplied by 2 to get y. So 4 times 2 is 8. Let's go ahead and start over again. Y equals kx. You see that we're given y is 16 and x is 4. I'm going to substitute those into their appropriate place. Y varies directly with x, etc. So 16 equals 4k. Divide by 4. K equals 4. Awesome. So that means we have the missing piece that we needed. Now we have y equals, and I'm taking k and putting it in for k. Right there. So we know that x is being multiplied by 4. That's going to happen every single time we plug an x value in. Times 4, times 4, times 4. Now we need to find x when y is 8. This is why we're paying attention to what is being asked. Always make sure we're answering the question. So when y is 8, so that means instead of substituting for x, I'm substituting for y equals 4x. Another one-step equation. Divide by 4, divide by 4. X equals 2. Now, we could set that up in a proportion and show that they're equivalent ratios. It's not necessary. But whenever y is 8, x would be 2. And this is how this is going to keep on going.